Hi everyone. So in this video, we're going to work through another Year 12 stats question from the AS 2018 paper. And this question has a mix of some mean, some standard deviation, a bit of large data set, and also some box plots. So Helen is studying the daily mean wind speed for Camborne using the large data set from 1987. The data for 1 month are summarized in table 1 below. So we have the wind speeds. Now, as you can see in that first column, we have NA not applicable. Remember from your large data set, if you have NA, you have to ignore these values here. Okay, so just ignore any value that is not applicable. So part A says calculate the mean for these data. But just before we get into the video, I want to make you all aware about a web app that I have created. Now, this app that you see on the screen here is designed to predict the 2027 Edexcel A-level maths topics that will come up in your 2027 exams. So now that the 2026 exams have finished, we now have access to those questions. So what I've done is I've analysed all of the questions from 2026 back to 2018 and also including the sample and the specimen Edexcel papers. And I've used that data to put together a model which will predict the topics for the 2027 exams. And if we just scroll down here, you will see how accurate this model that I'm using is. So if you do want to have access to the full predictions for the 2027 exams and also have access to a web app which will generate mock exam papers based on these predictions, that is what you can get if you do sign up to this app. Just go to the link in the description of this video, and also you can get the link to this web app in my bio. Click that link, sign up. You can see on the top right of the page here, you can sign up. Sign up to the app and you'll be able to access all of these 2027 predictions. Now, the easiest way to go about this question, and it's only 1 mark, is just to simply use the calculator. So use the stats menu on the calculator. Okay. So what you're going to do, you're going to go to your stats menu on the calculator, which I'm going to do right now. And in list 1, you're going to insert all of your wind speeds. Okay, so list 1 represents the wind speeds. So 6, 7, 8, 9, 11, 12, 13, 14, and 16. And then the frequencies are going to go into list 2. Just make sure in your settings that list 2 is frequency. Okay, so go to your stats settings and just check that list 2 is frequency for one variable, for one VAR. Okay. So list 2 is going to be 2, 3, 2 again, 2 again, 3, 1, 2, and then 1, and then another 2. So now we can press one variable or one var, one VAR, press that button, and then it will give you all of your summary statistics. So let's just write down here that the mean X bar, so remember, this is going to be the sum of the data. Okay, so sum of your data divided by the sample size. So from your calculator, you can see the sum of the data values here would be 184 for the wind speed, and then divide by 18. So then as your calculator will tell you, this will be 10.2 recurring. So 10.223 sig figs. Now this is about wind speed. So the units here would be knots. So remember from your large data, the units for wind speed will be knots. Great, so that's part A. Now for part B, calculate the standard deviation for these data and state the units. Okay, so with standard deviation, again, you've already got the number on your calculator, because remember on the calculator, the standard deviation, the button for standard deviation, the symbol is sigma x on your calculator once you've got your summary statistics given to you from your table. So you can write that down already, but because it's a 2-mark question, I'm just conscious that I want to show the examiner a bit of method just to prove that I know what I'm doing. So I'm just going to copy down the standard deviation formula. So it's this formula here. If you forget it, it is in your formula book, but I do recommend you learn this formula. It's not too bad to learn. And then you can copy down sigma x squared, which from my calculator is going to be 2062 divided by the sample size, which is 18. We have 18 days. And then the mean of 10.2 recurring that we found before, square that. And then we can just now write down the answer. Sorry, just make this square root extend a little bit. There we go. So our answer, as the calculator says, is 3.17 knots. So that is the units again to 3 sig figs. And that's our answer there for part B. Perfect. So now let's go to part C. Just another quick interjection. If you are currently doing Edexcel A-level maths and you feel that you're struggling or you're falling behind and you're not quite getting that grade that you need to get in order to get into university, or perhaps you're a parent watching this and you're worried about your child's progress, what you can do is you can head to my website. Now, my website is in my bio and also in the description of this video. Click onto the link and you can watch a brief video about me and my background. You see this video on the screen here. In this video, I outline the style and the structure of my tuition. You can also read some of my reviews and testimonials from other parents and students who have worked with me on this website too. So if you feel like one-to-one tuition is something that would benefit you in order to get the grades that you need to get, then again, just head to this website. And what you can do is you can book a free 90-minute call with me. And in that call, we'll spend some time discussing you, your situation, your ambitions, what you want to achieve, the grade you want to get, and why you feel like you're struggling and why you feel like maybe tuition is the right path for you. And we'll also spend some time basically doing a free trial lesson where I will help you out for free with any particular topics or any particular areas of the syllabus that you know you need help with. And by the end of the call, we can then discuss whether one-to-one tuition is the right path for you to get you that grade you need to get. So once again, the link to my website is in the bio and in the description of this video. So the means and standard deviation of the daily mean wind speed for other months from the large data set for Camborne in 1987 are given in table 2 below. The data are not in month order. So, okay, remember from your large data set, you have 6 months, you have May, June, July, August, September, October. So these months are the other 5 months that we've not talked about in part A and part B. So part C says using your knowledge of using your knowledge of the large data set suggests giving a reason which month had a mean of 11.57. Now, 11.57, if you just look at the data here, is obviously the biggest mean in the table, and it's bigger than the mean we found in part A. Okay, the mean we found there was 10.2. So this is the biggest mean. So month E has biggest mean. It's also got the biggest standard deviation as well, but it's certainly got the biggest mean. So the biggest mean wind speed. So out of May, June, July, August, September, October in Camborne, which again is in England, south of England, what do you think this month would be just based on a bit of common sense geography? It's probably going to be October because it's the closest month to winter. Okay, so let's make a note of this down here. Let's go down here. What was this? This was month E. So we can say that this month is probably October, since month E has greatest mean wind speed. And October is closest to winter. October is closest month in large data set to winter. So closer to winter, probably going to be windier, you would assume. Great, so that's part C. Now let's look at part D. So the data for these months are summarized in the box plots on the opposite page. They are not in month order or the same order as in table 2. Part D, part I, state the meaning of the star or asterisk symbol on some of the box plots. So remember from box plots, if you have an asterisk, these are outliers, okay? So let's just write this down here. Part D, part I, stars or asterisks or asterisks. I don't even know the plural of the word asterisk. Not very good to say that. So the asterisk represents outliers. If you do know the plural of an asterisk, do comment below. And then part II, suggest giving your reasons which of the months in table 2 is most likely to be summarized in the box plot marked Y. Okay, now let's look at this box plot Y. This median, so remember with your box plots, you have the lowest value, lower quartile Q1, median Q2, upper quartile Q3, and the biggest value right at the right side of each box plot. So if we look at this Y, I mean, we've got a median in the middle there. That's our median. This is the second lowest median. So let's just make some notes here. This is our second lowest median. So if you've got a low median, you would expect a pretty low mean because the median is the middle value. 50% of the data is here, 50% of the data is there. You would expect a pretty low mean for this one. So we don't want a big mean. So if we just go back to our table, I mean, straight away we can rule out E. It just doesn't make sense for it to be E. So let's continue and think about maybe the ranges now. So if we look at the range of Y, so this value there, I mean, that is, looks like 3 there. Let's just label that as 3. And then the biggest value at the top there looks like 15. So the range here is 12. Let's just say that the range is equal to 12. It's not the biggest range. Again, it looks like the second smallest range. Just look at the range of the other box plots. Looks again like the second smallest range. Let's just make a note of this here. Second lowest range. And then let's look at the interquartile range. So the upper quartile here looks like it's 10, 10 there. And then the lower quartile here looks like it's 5. So the interquartile range here is equal to 5. If we look at the other interquartile ranges, I mean, this box plot above Y also has the same interquartile range of 5. The one right at the top has a smaller interquartile range. The fourth one down looks like that's 6 to 11. That's got the same interquartile range. And then the last one at the bottom, 9 to 14, that's also an interquartile range of 5 as well. I'm just going to write down all of the other interquartile ranges just so we can easily compare the other ones. So the second last one is 11 to 6. So again, that's going to be 5. So interquartile range 5. And then this one up there, interquartile range is 4 for that one. And then again, with this second on there, interquartile range is also 5. So kind of hard to tell anything from the interquartile ranges because they're all pretty much the same. But that range for Y is the second lowest of those 5 box plots. So what can we say then? Well, if we go back to the table here, month A has the lowest mean. So again, month A, you would expect a low median, and it's also got the lowest standard deviation as well. So lowest mean, lowest standard deviation is probably going to be this second box plot there. So this second one, low mean, low standard deviation because the range is the lowest of the lot. So I would say that this one would probably be A. So let's ignore A because A doesn't seem reasonable. So now it's between B, C, and D. Which one our box plot Y is going to be? So B has the lowest mean of the 3. And if we just go to the remaining 3 box plots, and again, I'm just going to cross this one out here because the median here is so big and the range is so big. This is probably going to be month E, that last one there. So really, you've got option 1 there remaining, option 2 there remaining, and option 3 there remaining for B, C, and D. Now for our Y, we've got the lowest median. We've got an interquartile range, which is 5, which matches box plot 3, but is a little bit bigger than box plot 1. So maybe you would expect the standard deviation to be a little bit bigger than the smallest value we have here. So it's looking like it's probably going to be B because the mean there is the lowest of the 3 remaining. And the standard deviation is a little bit higher than the other 2. And as we can see, the interquartile range of box plot Y is 5, which is like joint biggest of the 3 remaining. So I'm going to say B with this question. So I'm going to go for box plot B. Now, I'm just going to let you into a little secret. In the mark scheme, you could actually go for either B, C, or D. You can actually pick either one. You're free to pick either one. You'll get a mark either way. It doesn't matter which one you go for, but I'm going to go for B. So let's say box plot or table month B. Sorry, let's just rub this out and say month B. So month B. So I'm going to say that the low median, so this has the joint lowest median. So Y has joint lowest median. Y has joint lowest median, which suggests that Y is going to have a lower mean. Y would likely have lower mean. And also, I'm going to say that the range for Y is bigger than the second box plot and also smaller than the last one. So let's just say here that also range of Y is bigger than the range for box plots above it, and also smaller than range of the box plot that was at the bottom. So the bottom box plot that I've crossed out there. So box plot at the bottom. So this suggests that the standard deviation is somewhere in the middle between the lowest and the highest. So standard deviation is neither smallest nor highest. So therefore B seems reasonable. But again, if you do actually check the mark scheme, you could say A or D as well. As long as you make a comment about the mean and the standard deviation, or the median and the range, then you'll get the 2 marks for this question there. Now, if you do have any comments or questions that you want to clarify in the comment section, do feel free to drop a comment, but hopefully this question does make some sense.